Let's now talk about array parameters and pointers. Please take a closer look at this program and try to guess the output of it, or maybe type it on your IDE and run it. If you have not seen such a program and if you don't know about this fact, then this program is going to give you some surprising output. Let's understand the program. We have a function fun where we are receiving ARR. We are getting the size of ARR. This is how we typically get the size of array, size of ARR divided by size of ARR 0. Then we are running a loop from 0 to n minus 1 where n is the size, and we are printing the ARR elements. Now in the main function, we are doing the same thing. We have an array 10, 20, 30, 40. We are getting the size. We are printing the array elements separated by space. Then we have \n, and then we are calling this function with ARR as parameter. So please pause this video and try to guess the output. When we compile and run this program, we get this as an output. So this thing is working perfectly fine. It's printing all the 4 elements. Then we have get a new line printed. When we print inside the function, when the function is called, we get only 2 elements instead of 4 elements. And the compiler on which I ran this program, the size of pointer was 8 byte and the size of integer was 4 byte. I think you might have guessed now. The reason that we are getting this output is array parameters, when they are received in a function, they are always received as a pointer. Even if you write a square bracket, it's of no use. It's always equivalent to star ARR. It's actually a pointer only, right? Even if you write these square brackets, right? I don't know why C and C++ compilers do allow square brackets here, but it's just a pointer, not an array. So what happens here is when you get the size of a pointer, you get 8 bytes here. And when you do size of ARR 0, as we have discussed in arrays and pointers video, this expression is equivalent to star of ARR plus 0. And we are getting size of it. So we are dereferencing an integer pointer. Dereferencing an integer pointer will give you an integer. So we are going to get the size of an integer. So we get 8 by 4, which is 2, right? So we are running a loop from 0 to 1, right? Less than 2 means 1 only. So we run this loop 2 times and we get the first 2 elements 10 and 20. That's why we got only 2 elements. Your compilers might throw a warning. If you're using modern compilers, the old compilers might not. The modern compilers might throw a warning that you are using size of inside a function, right? They exactly tell you what is the problem, right? So the problem is we should never use size of for an array inside a function. Whenever you passing an array as a parameter, do not use size of to get the size of the array. Now the question arises, how do we get the size of an array for a function? We should always pass size as a separate parameter, right? That's how these sizes should be passed. And if you see all the functions that we are going to discuss in the array problems, we always pass size as a separate parameter. We always do pass ARR comma n. We never compute size this way, right? It's never recommended. We should never use size of inside a function for array parameters. You may further verify whether it's actually a pointer by doing ARR equal to null PTR. This line would also compile because it's just a pointer, even if we have square brackets. So writing this or writing this, they are same. It's there is no change, right? You can write either this or this. They are always same. It's not like this is a pointer, this is an array. They both are pointers. Now you might be having this question, why C and C++ treat array parameters this way? They all treat them as a pointer. The reason is simple. When you're passing array or when you're receiving an array, you don't want to receive it by value, like normal value, where you copy all the content of this array to other array. This would be inefficient. That's a simple reason they implemented this way, that we receive always a pointer.